Exercise 1. Match each term with its definition by writing the letter of the correct definition in the right column on the line beside the term in the left column. So we have to first read the terms, then read the definitions, then match. Motion, reference point, international system of units, distance, the measurement of system used by all scientists, the length of the path between 2 points, changing position relative to another position or to another frame of reference, and a place or object used for comparison to determine if an object is in motion. So motion is C, changing position relative to another position. We consider an object to be in motion if it changes its position with respect to a specified frame of reference. Reference point or reference object is a place or object used for comparison to determine if an object is in motion or not. International system of units is the measurement system used by all scientists. Like what is the SI unit of speed? Meter per second. SI unit of distance? Meter. SI unit of time? Seconds. Finally, distance B is the length of the path between 2 points. It's the ground covered during motion. Answer by true or false and correct the false statements. A body in motion with respect to a specified frame of reference is necessarily in motion with respect to another frame of reference. No, it's not necessarily. It may be in motion or motionless with respect to another frame of reference. For example, if I am now sitting, I am motionless with respect to the ground. However, the same object, which is me, is in motion with respect to the sun because I am on Earth and Earth is rotating around the sun. So the same object may be in motion with respect to one body but motionless with respect to another. The shape of the trajectory of an object in motion does not depend on the chosen frame of reference. No, it depends on the chosen frame of reference. And you can go back to the example that I gave in the lesson about the ball that was bouncing in the moving vehicle. It appeared to be moving vertically with respect to the boy playing with it. However, it appeared to be moving on a curve with respect to an observer looking outside on it. Looking from outside on it. Now, an object is in motion if its position changes with respect to a chosen frame of reference. Yes, true. It depends on it. The SI unit of distance is centimeter. No, it's meter. Convert the following: 278 centimeter. From centimeter to meter, you have to divide by 100, so it becomes 2.78 meters. 125 kilometers, you have to multiply by 1,000 to convert it to meters, so it becomes 125,000 meters. And from millimeter to centimeter, you have to divide by 10, so it's 630 divided by 10 is 63 centimeter. Write the letter of the correct answer on the line at the left. Jane is sitting in the family car. Her mother is driving her from their house to the library. Jane waves as she passes her friend Marina. Which of the following is not moving with respect to Jane? Marina appears to be moving away with respect to Jane. Jane's house is moving away from Jane because she left the house and she's moving away from it. The library appears to be moving closer to Jane because her mother is driving her to the library. However, the only object that is motionless with respect to Jane is the car itself, because Jane is not changing her seat. That's why the car appears to be not moving with respect to Jane. Now, which of the following is the best reference for describing the motion of the planets in our solar system? So describe the motion of the planets in our solar system. You have first on option A, spaceship in orbit around the Earth. Actually, this is really negligible with respect to all the planets. Plus, this may be at a temporary spaceship present around the Earth. So it's not really convenient to describe the motion of the planets with respect to it. It's possible, but not that convenient. Now, B, the center of the Milky Way. Milky Way is actually really a huge space that our solar system is just part of it, and the planets are part of the solar system. So the planets are also considered negligible with respect to the whole Milky Way. So and actually the center of the Milky Way could not really be determined. So it's not convenient to choose the center of the Milky Way to be the frame of reference. Now the Earth, yes, we can describe the motion of the planets, other planets with respect to the Earth, but finally they play the same role in the same system, solar system. So actually what is really the best reference is the sun, because they all rotate around it, and it's permanently in the center of the solar system. That's why we choose the sun to be the best reference for describing the motion of the planets. A crow was flying along at a constant speed, carrying a ball. Suddenly the crow dropped the ball and watched it fall. So he threw it so that it moves on the parabola as shown here, on a curve as shown in the figure. The diagram below shows the position of the crow and the ball at successive positions. The time separation between one position and the successive one is 1 second, and at the same time a boy was standing still on the ground, watching the ball fall down to the ground. So in part A, taking the crow as a reference, give the shape of trajectory of the falling ball with respect to the crow. It's a vertical segment because each time the crow moves from one position to another, the ball still appears to be under it but moving downwards away from it. So if you join the successive positions of the ball with respect to the crow, who's always seeing the ball below it, it's going to be a vertical segment. Now part 2 indicate the total distance covered by the ball and the time needed to reach the ground. Deduce the average speed of the falling ball during this time. So the crow threw the ball from a height of 100 meters, and it needed 6 seconds to reach the ground, so 100 meters. And we said here in part 1 that the ball appeared to be moving vertically on a vertical segment whose length is 100 meters. So V average is distance by total time is 100 meters by 6 seconds. Both are given in the SI unit, so the average speed is 16.66 meters per second. Part B, now taking the boy as a reference, give the shape of the trajectory of the falling ball with respect to the boy. Here, yes, the ball appears to be moving along the curve that is shown. So if you join the ball, the successive positions of the ball shown in the figure, you obtain a curve with respect. This is the trajectory of the ball with respect to the boy. Finally, a large merchant ship had illegally anchored at a distance from the seashore, so it stopped there. The document below shows a troop of the Marines sailing their boats towards it for investigation. So they are sailing and it is anchored. Okay, so determine whether the Marine soldiers are in motion with respect to the ship. The Marine soldiers are in motion with respect to the ship because their position changes with respect to the ship. They are moving towards it. The distance between them is changing, and thus the position changes. Now determine whether the ship is in motion with respect to the boat. As long as they are sailing their boats towards it, distance between the ship and the boat, the ship appears to be moving closer to the boat. That's why it's considered to be in motion, because the position of the ship changes with respect to the boat.